What is up, Unity community, and welcome back to another official Unity live stream here on twitch.tv/Unity and, of course, the Unity YouTube page. My name is Jackson. I am one of your community managers, and it is my responsibility to bring you all of the live stream content you see on these channels. And we have a fantastic show planned for you today, as we are going to be diving into developing with dots with the team behind Dawn Apart, and we will be bringing back a familiar and wonderful face from Unity as well. That's right, a wonderful face. Of course, it is our hope that you come to these streams once, usually twice a week, and connect with your fellow Unity community. You leave feeling a little more inspired, educated, informed, and capable to take on your own development journey. And wherever you are watching, whether that's Twitch or YouTube, live with us here today, please be aware that this is a conversation and we see you, and it is my job to connect you with our guests to bring your questions and get them answered wherever possible. So whether you're watching on YouTube like Silent Wraith, The Mastermind, The Bull, Fredo, Mr. Awesome, Diane Parker, and many more, or if you're over on Twitch like Jack Moenman, Andrew the Day, Scallywag, and Laurent, we are paying attention, so please be aware that this is a conversation. If you are watching after the fact as a VOD on YouTube, please take a look down at that navigation bar, as it will be conveniently chaptered for you to jump ahead to whatever portion of the stream most appeals to you. You can even watch the stream at 1.5 times, which some people have told me is better. So you can always enjoy that. But like I said, we have a fantastic stream planned for you all today, and we will be doing a giveaway as well. So if you want an opportunity to win a Steam code, a Steam key for Dawn Apart, stick around to the end of the show and we'll be having that giveaway happen. But thank you again so very much for being here. As always, very curious to know where you are tuning in from. As a community manager, seeing people tuning in from all over the world is one of the most rewarding possible things. So please drop, as vaguely as you would like, your location in the chat, because it would be great to see. Johnny Turbo in the house, Mr. Awesome, not today. However, we were just talking about maybe bringing Turbo back for a stream in future here. So we do want to set expectations here. Albert B saying, very excited for this tutorial stream. We will not be doing a tutorial directly. We will be talking to a team that has used dots consistently throughout their entire project. They will be opening it up and sharing their insights, their journey, their experiences, answering questions. So there'll be a lot of knowledge here, but don't expect a step-by-step tutorial like we have frequently done on these streams. With all of that being said, we're going to bring in our guests here, but first, to set the context for the stream and so that you know what game we're even talking about, we are going to throw to a trailer for Dawn Apart, and when we get back, we'll be joined by all of our wonderful guests. See you in a moment. And with that, we are back and joined by our friends. Please welcome back to the show, Unity's very own Laurent. Great to see you. How are you?
Yay, I'm doing great. How are you doing?
I'm doing very well. Thank you for asking, and thank you for being here. And of course, we've got two new friends from all the way across the pond, as they say. We've got Tony and Thilo. Welcome on in, guys. How has your day been so far?
Yeah, it's been great, and yeah, we've been looking forward to this for a while. Yeah, it's really exciting to be here.
Great.
Absolutely. Awesome.
Yeah, thrilled to have you both. Thank you for, of course, it's hard for people to understand sometimes that, like, we are live for this 90 minutes, but we have been working as a team to put this together for a handful of weeks. So thank you guys for being great partners in this collaboration for sure. Before we get into talking about Dawn Apart and what the game is. I'd love to get to know the people in the room a little bit here. So, Laurent, let's throw to you first. You've been on streams in the past. People are hopefully seeing a familiar face, which is always exciting. But if anyone has not been a part of some of the content that you've been on, can you tell everybody a little bit about what you do here?
Yeah, going on streams is kind of like my secret, favorite thing to do, even though I'm doing like a bunch of things at Unity. But yeah, I've been around in games for, I don't know, 20 years-ish. That hurts to say it. But anyway, been doing game engines, been doing a bunch of things. I joined Unity about 5 years ago, trying to like get back into game engine business again. Been doing a bunch of product management in various places across the engine, in services, in multiplayer, etc. And at some point, I joined the Dart team, like especially when it was a little bit more difficult for that team to get to market for version 1.0. But we got there. We finally been able to release a bunch of that value, and that was pretty exciting. And that's roughly at the time I started doing live stream. Sitting down with game developers and just looking at like the amazing creative ways to turn around any kind of tech we can ship to the market and just make it do whatever it was not intended to do. And that's always amazing to observe. And so we're kind of having this chat is fantastic. So really, really excited to be there and dig deeper into that specific game.
Yeah, thrilled to have you here, Laurent. And we've got Scallywag Me in the Twitch chat saying, Laurent, was a pleasure meeting you at events in the past. And Laurent, I had the pleasure of watching you do a presentation in Finland last year. If anyone has an opportunity and Laurent is nearby, go out of your way to go and check out what he's presenting, because there's a lot going on and a lot of really cool insights that Laurent brings. As an effort to get to know you just a little bit more, Laurent, do you have a favorite game?
What? Like it's asking your favorite child. What
I know, and I never stopped doing it.
So maybe maybe recently. Well, actually, I've been like studying like some of the games that we were preparing for live stream. So I've been playing Dawn Apart quite a while recently.
Oh, that's great.
Yeah, and some of the other games that we would like to do some streams about, but we'll talk about that when the time comes.
Very cool. And now is a great time to mention that the Laurent receives no royalties for mentioning Dawn Apart in the stream. So
yeah, we give you a key.
It's really my kind of game. Like as a player though, like when, oftentimes in simulation games, like there is like a nice ramp up at the beginning and at some point complexity explodes.
Right.
That's when I'm like, oh, I'm not sure I can go there. Like it's so large and complex.
Yeah. I love it. Well, Laurent, welcome back. Always great to have you here. And I think we should go around the horn here a little bit. Thilo, let's turn our attention to you. If you can tell us a little bit about your history and your journey to get here, and then also what you do at IT&W.
I'm the game designer at IT&W, and it's basically called Industrial Technology Witchcraft, which is a homage towards some Industrial Light and Magic from Lucasfilm and LucasArts. It was like the games I grew up with and loved playing these. My journey is I'm actually a software developer myself. I started making games as a kid, selling them on the schoolyard for 5 Deutschmark and a floppy disk, because I give you a floppy disk and you give me one back. And did that for quite some time, and then started a corporate job working in software as a service. And we discovered my passion a couple of years ago and started making games. And in my past job, I met Tony and we connected with each other about games, and then so we decided to make our own studio. So Tony's a co-founder, I'm a co-founder of Industrial Technology and Witchcraft. And Dawn Apart is actually our second game. The first game was like more, let's test out if we can actually make a game. And Dawn Apart is about our biggest game so far.
That's awesome. I love all of that, genuinely. The reference to a VFX house, especially a monumental one, and then selling your games on the schoolyard for $5 and a trade of a floppy disk is fantastic. Now, Tony, maybe you take a moment to prepare this, because I'm going to ask Thilo the same difficult question, but do you have a favorite game?
I do. Can I name 2 games? So
please.
Okay, well, one game which I strive in is Squad. It is one of my most favorite games. And it actually turned out to be, it was once a mod for Battlefield and then turned into a game. And that's also what we thought. Looking for mods out there and supporting the mod community, and then make standalone games out of that. That's actually how Industrial Technology Witchcraft was born. Yeah.
Oh, that's
But
awesome.
but I have to shout out. I mean, the game with the most hours is definitely RimWorld.
Which one? Sorry.
RimWorld.
Oh, yeah. Okay, well then we see the inspiration, I suppose. That's
actually,
awesome.
like if we're counting in number of hours, I think mine was Civilization 6.
Okay.
I was taking last time on my Steam library, and I was like, oh, that's a lot of hours there.
Yeah, I think the keeping an hour count is a blessing and a curse. Like I remember my World of Warcraft days going in, and it wasn't counting hours; it was counting days.
Right.
I need to stop. So, but Thilo, welcome to the show. Thank you for the background as well. Tony, turning our attention to you. First question I want to ask here: Oregon Ducks hat?
Oregon Ducks, yeah. That's where I grew up. I grew up a little bit north of Corvallis and Eugene, in Beaverton, right outside Portland, basically. And I moved over to Berlin like 6 years ago now.
Wow.
And
okay.
Yeah.
And was that move to start ITNW and get started in the industry?
No. My wife and I just wanted to try out something new, and it was like the perfect time. We had no real ties, so we just said, let's try and make this happen. And I just happened to get a job there. So the first interview I went over there, didn't have a job, just kind of like saying, okay, well, hopefully I'll get one. Got this job. That's where I met Thilo, and then some stuff happened, that job went away, and then we founded this, and so it just worked out like really strangely and perfectly.
That's awesome.
It's really
that's
cool.
Awesome to hear. So then what as a lead programmer, what are your kind of responsibilities? What have you been working on in terms of Dawn of Heart?
Oh yeah, I mean everything. It's we're living the indie dream, really, where I wear every hat, including this one, the Ducks one, and it's everything. It's voxel engine development, it's game systems, it's rendering, it's UI, it's whatever needs to be done. Basically, that's what I'm working on. That's what our other developers working on. So it's really just across the board, like. So much stuff. We originally started, we had like some years where really was just basically Thilo and I, and that's where like a lot of the base functionality kind of came in, and now it's our team's like slightly expanded, and there's less more people to take on more stuff, but even still it's everything.
Do you have like
indie spirit?
Do you have like any kind of trick to share about like how you get to real milestones when you have so much to worry about?
Yeah. Well, yeah. So we use Miro. I would definitely recommend using something like that. Yeah, we're full remote. But because we were software developer, like professional software developers before, we were like really used to Scrum and like having pretty good processes in place. And that's really important, to like get these early and like do your sprint plannings, make tickets, and we've kind of gone back and forth about this because, Scrum is to me, it's not like the perfect fit for game dev, just because not everything can be done in a sprint. Like you might have a sprint to do a feature, but you have to do, like the sound effects, the UI, like there's so many things that just have to be done that you cannot possibly hit them all. But I definitely recommend getting a board, getting sticky notes, and start doing that.
Yeah, that's the core of it, isn't it?
And have milestones in the first place, actually. So
that seems like an organizational.
So, I mean, like with a date on it, and
I mean, milestones is like that's easy. It's meeting them that is difficult.
Right.
Usually, it's going like, okay, well, I mean, in 3 months we have to get this done, and then looking at each other and then going like, okay, what of the features which we have in our mind can be dropped now and still come out with a product people can play with. And I mean, like the first year we were working on this was more of let's tinker around with technology. Let's find out what can we use, and but in the end it was like, okay, well, now we have to figure out what can go in the game and then stay in the game, and what has to go out. And so we kind of, for early access, had to cut a lot of stuff which we wanted to deliver. But in the end, I mean, we're going to talk about early access later on this stream too. But we had a fantastic game suddenly when we decided, okay, well, what is working and what can meet that deadline for release.
Yeah. I feel like talking about managing scope and scope creep and is like a constant conversation, which is always a really, really fun one. So before we get away from it, Tony, I would love to hear your submission for favorite game.
Yeah. So I also have a few. I would say that like the top would be Red Dead Redemption 2. I think it's it's a like a technical marvel. It's incredible. Yeah, and I actually still play the online, even though it's like gotten no love in a long time. Yeah, and then outside of that, I would say like next, like the game that I have the most hours in is actually Counter-Strike.
Okay, nice.
Yeah, because I played that ever since I was a kid, and actually mostly I like surf and bunny hop. I'm like much more of a movement player, like a movement shooter type. Yeah, and so it's a little different because simulation games like aren't normally my cup of tea, but I do like, you know, deep systems. And then I have to give a shout out to Trackmania, which is which I'm pushing on everybody because I just think it's the best game I've discovered in, you know, like the last 2 years. It's just incredible.
That is fantastic context. And we've got a surprise for you when we finish the stream because producer Jack has news to share with you. But before we dive into talking a little more about this project, Laurent, I'd love to give you an opportunity to just kind of talk about DOTS and ECS and lay a foundation for anyone who might not know what it is, because we are getting a couple of questions. Someone asked, is DOTS still the future? Which is great to see. We're seeing a lot of people being like, you know, I'm dabbling with it. I'm curious about it. One of these questions is, why choose DOTS for your game system? So give us a little bit of a foundation, and when is it a good time to pick DOTS and ECS for your creations?
Yeah, it's a very important question, because that's not like, we're not suggesting that everybody should be using ECS. It's really a weapon that you should deploy when you actually have a target that fits the size of it. So basically, like if we just track back just a little bit to where that's coming from, I remember when I joined the team back 2021, maybe, my first onboarding meeting with Joachim, one of the co-founder of Unity, he was telling me, look, I started the architecture of Unity when I was 19. I made mistakes. I want to fix it. That was pretty much where I was coming from. I was like, yeah, okay, fair enough. But, you know, like, how do we tackle the problem is something that is very complicated, because Unity is very mature. It's everywhere. Like, there was so many games, so many different genres built on it. And so some of the things that he had cooked originally in the architecture of Unity is this, not exactly maybe the very first version, but some of the like early version of Unity is this strong foundation on the .NET framework and mono behavior ecosystem. And that ecosystem is super easy to pick up, super easy to get into, which made a lot of the success of Unity, but it's also unpredictable. Like memory management, CPU consumption, execution of code, all of that happens a little bit all around the place at any time. This garbage collection kicking in anytime. It just spikes into your frame rate. And the minute you want to like use that, you know, last 5-10% of the hardware of your device to maximize what you can get to your players, then it becomes very, very difficult, because like the tech of Unity, the classic foundation is not predictable enough for that. So we started introducing, initially, like we wanted to redo Unity from scratch. That idea didn't fly too long. And then at some point we're like, okay, let's introduce at least one part of the ecosystem where you can sit the gameplay on, and that framework will be based on the best practices for AAA game development, where we do a very great separation of concern. There's the data on one side, there is the code on the other side, and the entirety of the framework is deterministic and not reliant on managed code, where you don't really control what's going on with the memory and the execution. And so that's ECS. It's running outside of the ecosystem of .NET. It's like really lower foundation. It gets posted to native code, so it's very, very fast. And you can scale dramatically to a large number of entities. So when should you use it? Rules of thumb. If a game in, let's say, 2021 LTS was doable without ECS, then probably you shouldn't worry about it. If it was doable before, it's still doable today with game object and monobehavior, and that's all fine. Now, if you start to get into a land where there is complexity and you're having like some trouble to get to a performance you need, then maybe you should start introducing ECS for a specific part of your gameplay and progressively expand that. So when is it a good time to use ECS? The rule is pretty simple. ECS stands for Entity Component System. When you have a large number of entities with a few number of systems, that's where ECS is at its best. So let's say, for example, a physics simulation is awesome on ECS, lots of object, and just one simulation. If you get into the other way around, when you have very few entities and a large number of systems, that's the weakest for ECS. So that's a situation where you might not want to use it. Let's say, for example, very complex, UI where basically it's tons of little system with tons of little different behaviors, but very few objects to work with. So that's in a nutshell when ECS gets useful.
That's awesome. Thank you very much. Oh, give me 1 second here. Much better. Thank you for that overview. We're going to dive in here to talking a little bit about Dawn Apart and then getting right into the nitty gritty about Dots specifically. If you, Unity community, have a question, please feel free to drop it into the chat. We'll try our best to find an opportunity to bring it to the team here. If you see me looking to the side and typing, I'm responding to the chat. So I am here. I'm fully present. I promise I can multitask. But Thilo, Tony, how do you typically describe Dawn Apart to anyone who's never seen it before?
Okay, usually. So, but they're gamers, right?
They're gamers.
Games? Okay,
Yeah,
good.
yeah.
Well, I say if RimWorld and Factoria have a baby, then it's
okay.
Apart.
Easy peasy. We got it. We got there. Super quick. So how long was the process? How many years were you working on this? And where is it at now? Fully released, correct?
It is released in early access on Steam.
Okay.
And we started, I think it's now 3 years. That's also when we met Laurent at the GS, and we talked about Dots, and we told him we're going to make a game in Dots. Dawn Apart is a colony sim where you build a factory. It's an automation colony sim. I think it is one of the first of its kind because there are so many moving parts, which were only possible with something like .ccs.
Gotcha. Lots more that I'm sure we'll learn as we go, but as a general overview, that's what Dawn Apart is in a nutshell, I suppose. And we are putting links to it in the chat, so if you want to go and follow up, take a look at the Steam page. And like I said, we will be giving away multiple copies at the end of the show. I think that it's time that, Tony, we turn our attention to you. We've set the stage. The spotlight is yours. And I know that you've got a lot to talk about and show our Unity community here. So did we want to get started on constructing conveyor belts and custom editor tools?
Sure. Let's do it.
All right.
Okay. I guess just first slide, just to get some details out of the way. We are using Unity 2021.3 LTS, and we are on entities 0.51. So we are not on like the latest version. So, it like there might be some API changes, and your mileage may vary, based on what we're going to talk about. But in general, everything should be transferable. And also just a note here, we started like very early on with Dots with 0.11, which was a very early version. That's
in
it.
Between 0.11 and 0.50, there's like a dungeon there.
Yeah.
Is there a strong reason why you're still on 2021? Like, is there just because you're comfortable there, or is there an actual very strong reason where
no
you want to stick there?
Yeah, it's really just that, like, there's a lot of things that need to change to get to a newer version, and basically, like, we came to a point where we were still working on the game, and like, our deadlines were coming, and we kind of, Thilo touched on it. you know, that like we had to make some kind of sacrifices, and you know, this is one of them that just like, you know, I have a branch that I've been keeping updated, and basically I just you know, we just haven't had the time to really like dig into that and get it to the next version. Yeah, but I think at some point, you know, once we're at like a more comfortable spot, we'll you know, tackle this again. Yeah, beyond that, yeah, the game runs. There's a custom voxel engine that we built on Dots. It's called God Mode, and around 80% of the game logic is in ECS. So basically, like everything in the game is mostly an entity, and I'll touch on that a little bit more. You know, things that can't be, you know, that need to be game objects, like lights, visual effects, the UI, and some of the higher level logic that doesn't really fit into systems. You know, like singletons, like managers for quests and trades. You know, those things kind of still live in mono behaviors.
I'm not sure if you want to touch on that later, Jen. Just tell me to shut up there. But what was your general like experience with VCS in terms of concept? I was seeing somebody else, you know, in the chat mentioning like some of the distance that exists in classic, you know, Unity development versus CCS and the concept and the architecture behind it. Like, was that difficult for you to get into?
Yeah, I think. Well, yeah, I guess it was like so long ago now. I think it kind of was, and we were kind of talking about that before the stream. You know, that like I think that when I was getting into it, you know, it was a lot of like digging through samples and like just reading the documentation and just like trial and error, basically. You know, it was like spawning, you know, just some cubes and then moving some cubes around and adding, you know, just more components and more systems and just playing with them. You know, and at this point it's fairly natural, but what I was saying is you know, like we've had other developers that come on and you know, sometimes it's not like a very smooth like onboarding, right. You know, even if they are Unity developers, you know, so it is like more programming heavy, you know, but like what I always tell them is like, you know, at the end of the day, it's just data, you know, like whatever you want to be doing, just try and, you know, break it down into like, these are just components. There's some data, you want to do something with them, and, you know, you're done. Yeah. Thilo always says like, oh, it's just some if else. And, you know, maybe I also simplified too much, but, you know, that's how I like to think about it.
Yeah, it's also some feedback that I got like from many developers. What happens oftentimes when people get exposed to ECS for the first time is that it's definitely a shift from what they've been used to before. Mm-hmm. But it also solves so many other problems that you used to have and that you don't have anymore. That it takes like, that's the initial exposure gets like mentally difficult, and then you get to a point where you're like, oh, now I'm testing new gameplay systems, and you add them, and it's like flawless because you basically have that nice separation of concern, and so you're just playing with more data, more system, less system, and the rest is pretty much stable. And that's when like it starts to get more fun. So it's also the kind of conversation we have at Unity, like wondering how do we make that initial step, you know, smaller, smoother, so you can get to the fun quicker. But yeah, it's difficult.
Yeah, and I totally agree with that. Yeah, like the sub-scene workflow and everything. You know, once you kind of have the experience and get used to it, you know, because it's like such a different paradigm. You know, then it clicks a little bit more. You know, you're totally right. There's like some small speed bumps right at the start. It's like very front loaded with speed bumps, and then it's very smooth.
Yeah, we've got Scallywag me in the Twitch chat saying it's completely different mindset, but once it clicks, it's a really enjoyable workflow. So yeah, it seems like we've got some community members sharing that sentiment as well. We are shooting for about another hour for the stream, so I want to make sure that we do have enough time to kind of get through everything that you've prepared, and I know we've got a lot ahead of us. So why don't we get started on everything you have here for us?
Yes. Okay. So on to conveyor belts. Yeah, so conveyor belts, you know, like Thilo said, this is an automation game, and, you know, conveyor belts are like synonymous with automation. And from like the original idea, right, we wanted 2 lanes, so not just like 1 lane. And then also we wanted these kind of like dynamic types, you know, which would be corners or junctions. and things that can merge onto other lanes. And then basically we wanted these to be able to, you can extend these or destroy them however you want. And they also need to be scalable, obviously, like into the end game, when there's a ton of stuff. So yeah, I guess here we go with some implementation details here. Yeah. So I won't go through all of this, but essentially the way our system works is like we have, at the highest level, a thread group, like a conveyor thread group. And this is just like a group of conveyors that can safely, update on their own thread. So we can run a parallel job and all these items can move on their own thread and they won't cause problems. And normally this means that like the conveyors are not connected whatsoever. And then a lower level is the thread or a conveyor group. And it's basically the thread group just keeps track of all these conveyor groups. And then conveyor groups are made up of conveyors, which are also an entity. And but this higher level conveyor group handles things like keeping the items, keeping track of the items, whatever's on the left lane, the right lane, any outgoing or incoming requests for items, or any junction merge requests, basically. And then if you go down even further, then there's the conveyor, which is kind of, this is like the visual piece of it. But that keeps track of like the waypoints, for items that are on that conveyor. They check the waypoints from there. And yeah, but that's about all they're really used for. And then items are just items that are on there.
It's oftentimes something that people are struggling with VCS is like, how do you do dependency management? That's something that people kind of like always having some sort of trouble about. So did you take like multiple paths for designing this, or did you have like a good idea from the start?
Yeah, I mean, the conveyor system is probably one of our like earliest systems, and it's gone through like some number of iterations. And so this was kind of, I don't know if this is like the final solution, to conveyor belts, but we definitely did like start initially with, running the jobs on conveyor groups instead, because these can update, but then there were some issues, mainly race conditions, because if you're updating all these items on multiple threads, there are problems where like an item might come in or get taken, at the same time that it's moving, and other things need to know that, there's an item in front of it. So we definitely took in like a lot of considerations to make sure that it, works fine on multiple threads.
And like in a simulation game, you can't just simulate only what you see. Like you have to simulate everything all the time.
Right.
Like what kind of complexity are you able to get to? Like, do you have still room in the game to grow, or do you start to hit some limits at times?
I actually think that we do. Yeah. So we've gone through like a number of iterations of optimization, and actually like most of the bottlenecks we hit stem from like the voxel engine, like rendering bottlenecks. So we're like GPU bound, or the physics, because basically we have like these compound colliders for voxels, and what we really need is to make a custom physics collider that uses the voxel data. And this has like been on our plate for like a while, and so like it kind of comes to a point, where we say like, okay, we need to optimize something, and then we break out the profiler and take a look at the jobs, take a look at wherever we're doing any like dot completes, and say like, okay, these need to change, what jobs aren't we bursting for whatever reason, and how can we get these bursted, which a lot of times includes like some crazy workaround, just to get all of our data in a way that's not managed whatsoever. So there's like a lot of iteration for us, and I think that'll just be an ongoing thing, basically just optimize, because obviously like with sync points and everything, it is actually easy to kind of ruin your performance, if you're not careful. So
Clearly.
yeah. Yeah. So basically this is just some more information. These are the jobs we have. We have 2 separate jobs down at the bottom here. So one that actually moves the items on the conveyor and that just runs over the thread groups. And then one of them that is, that handles the merging. So these don't happen at the same time. They're totally separate. So with that, we just, update all the items, and there's some like additional information here. Here, let me actually just break out this.
Hey.
Yeah. So here's the
Look at
game. So basically we have our conveyor belts and they work. Things move on them. Just like this. So if I add some overrides, we'll be able to kind of see this a little better. And so what I was talking about is like these are conveyors. Here, then let me pull up some stuff. So we have some visualizing stuff. So this actually shows like what the groups are. And so like each of these in a different color is a different group basically. So anything that doesn't like merge together will be another group. And actually if I end up looking at the handles here, and I don't know how this really looks on the stream, but the important thing here is there's this thread group ID. And so you can see that like this conveyor belt and this one can update completely separately. But if I were to, build a new conveyor belt chain here, then these are going to be merged into the same thread group. And now we have to update these groups kind of sequentially on a thread, although, these ones are totally free to keep going on another thread.
So basically like a player could get in trouble performance-wise if they were to interconnect everything together.
If they were, but so that is the worst case. That would be the worst case. But even still, like we have a lot of things. Like if you kind of look at the way the conveyors work, and I thought I had this in the slides, but essentially, if you look at conveyors, then we have this front item moving, and basically, if the front item moves, then we know that everything behind it can at least move that distance. And so we can actually get away with like merging these item groups together. That was what was in my slides here. So there's an item group which contains also a buffer of items, and this would be like some number of items that have kind of like come together, and once they're together, they can be merged into one group. And then if we move the front one, like we don't have to even check anything else. We just know that like the one behind it, if it's in the same group, it can move the same exact distance, and so we can get away with like quite a bit of skipping a lot of logic, basically.
Pretty smart.
The idea came from this what's it called? It's a like Factorio Friday thing. Yeah, they have some amazing posts that we're like constantly siphoning from.
Cool.
So these are just some of the kind of things that we've made, because sometimes working with entities, it's not the same as like a game object. Like I can't go into the scene view, for example, and like click on these and select a conveyor belt. But what we did do is there's like a function, so that like if you click on these in the dots hierarchy, and by the way, if you're using dots, like break out these windows because they're incredibly helpful. So we just yoinked the same function. So if something's already selected, I can press a keybind and just select it like right away. And it has to be through the game window, but this at least is pretty nice. And then this is maybe like a good time to talk about it, but like it's also really important, I think, for like a lot of the developers to know a lot about the systems and like the components, because like, for example, there's so much data here, and like if somebody new comes, they might not know that there's like some reference to a conveyor group here, and they can just click it, and then they're in this conveyor group, and with all this other information. So there's actually like a lot of really, really helpful stuff. But you need to be ingrained a lot in it, which is really the benefit of having built a lot of it. I guess for conveyors, there's not that much else. I mean, that's like the core of the system. But I did kind of want to talk about some custom editors. Yeah, so obviously we had
I was about to ask for that, like if you could clarify what is custom and what is not.
Yeah. So basically the way that we have done this is we have a manager which kind of holds these buttons, and then we have a conveyor debug system that kind of pulls for these. So this is like a separate system that only runs in the editor, and basically we just on the update either run some jobs or don't. And we do this actually for a lot of things. So like for our stockpiles, which is like our storage management, or for agents, or for smart objects, we kind of have like the same kind of thing where it's at times completely unhelpful, so this is actually what it looks like a lot, is like getting right up here, and you can see like exactly what you're looking at, what entity, like certain information about it. And this has been like hugely helpful just to have like some more context in the world. But these are mostly like ones that show up in the editor, and then we've also made like other editors, which would be here. And these are mostly like built in UI toolkit. Because we love UI toolkit basically. We used to be web devs, and it's like exactly exactly what I was looking for. The base game doesn't use UI toolkit, but like building certain things like this, where basically we can take a recipe, for example, and see exactly the recipes and things like that, and basically like simulate exactly. I'm dropping some stuff off the bottom, but and actually like simulate out exactly how much time these things would take if you did this in real, like in real world seconds. We can start to kind of.
I bet the players would love to get that tool too.
Sure. I mean, we've had like a choice between doing this in an Excel file by ourselves, or
the good news is
make a tool in Unity directly.
That's based on UI toolkit. You can run that in runtime, can you?
Yeah. I love making custom tools, and then my biggest nightmare is when somebody on the team says like, "Oh yeah, this would be cool in game." Yeah, right. I know. Yeah, right. Yeah. Because like this is like, you can click all over the place. Yeah, it's really cool. It's really, really cool. Yes, this is used for a lot of things. And then similarly, we have that's
what I was referring to like earlier in the stream when I was saying, when the complexity explodes in a simulation game, it's like you need to start a spreadsheet and like, do project management to understand how many of the initial recruits you need to build up your factory. Like that tool sounds amazing.
Right. Yeah, exactly. Yeah. And then separately, we have this other one because our agents are not like behavior tree agents. We have this like goal-oriented action planning, and it's like totally opaque what's happening. Like getting a view on it and figure out why they're doing stuff is like a constant problem that we have where actually things are working, and sometimes players don't think they're working because they do things that like maybe don't make sense because like the schedules or priorities, things like that. And it's like this another like kind of rough looking custom editor that basically shows us like exactly like what they can be doing, what they can't be doing, and actually the priority of the goals. So this is like very helpful for our specific game, and it's another just UI toolkit editor that we spun up.
Did you have any difficulty to run like ECS in the editor? If I remember well, in 050 there was some tricks to do there.
Mm-hmm. I don't really think so. Not too much. I mean, yeah, no, I have like all of the stuff here. I mean beyond like, you know, there being some quality of life stuff that I kind of wish there was. You know, there's like a lot of stuff. Yeah, actually, I never use these these components or archetypes, but I do use the systems all the time. You know, and this is actually like one of the strongest things, you know, is that like you can just look at all your systems. You know, we have so many systems basically, and you know, just disable them. You know, like for example, you know, the on conveyor, if I don't want this to run, you know, for whatever reason, just disable it, and you know, these are going to stop. You know, and this helps a lot with debugging and kind of like finding specific problems, you know, with systems.
But now I'm my memory is fuzzy. But we do have a UI for that now in 1.0, don't we? Or maybe I'm badly remembering. I would have to check.
Well, now I'm nervous that that's like a future thing that we're like. That's fun.
Yeah. I mean, that's kind of what I was saying is you know, basically whatever we have, like, and whatever we're using, most likely there's better tooling at this point, you know, like down the line, you know, that's like the most alluring thing about moving to 1.0 is like, you know, actually mainly enableable components, which kind of, it looks like we're being implemented in this version, but not like completely finished. And these would be like really nice for us.
That's awesome. That's awesome.
Yeah.
Are we ready to kind of transition into something that I'm quite excited about, but the voxel material stuff, or is there more that we wanted to kind of touch on here?
No, if there's any other questions about conveyor belts, I'm happy to talk about them more.
Ultimately, we do have a dedicated section at the end of the stream as well, if there's any questions that kind of get missed along the way. But yeah, I think for now we should be good to roll on.
Cool. Yeah, then I guess moving right along. Yeah, basically, let me actually make this bigger. Yeah, so just some considerations. Yeah, this is like a very early version, but you know, Dawn Apart was really always a voxel game, you know, from when we planned it. And not even really, you know, like voxels as in visuals, you know, but like we'd always wanted, you know, like some kind of deeper interaction behind it. You know, this was kind of at the same time that games like, you know, Teardown were coming out, and there's like all these really cool voxel projects happening. And yeah, so we just ended up saying like, yeah, you know, let's go for this. You know, we'd already made our other game, you know, which had, you know, it was 2D, but it had a lot of like the same really dynamic destruction. You know, so we just wanted to go and bring it into 3D. Yeah, and so we found that they're like very divisive. Some people don't like voxels, some people do. You know, it's I guess that's as simple as it is.
There's so much like game that are hugely successful with voxels. I'm kind of surprised you got like so much divisive feedback.
Yeah.
Maybe it's just like taste, I
don't
guess.
know. I mean, we knew when we started that we couldn't afford AAA graphics, and honestly, we always loved destruction in games. I mean, starting with Red Faction was a game of mine, which I played like many times. And so very early on, voxels came up as an idea, and we quickly fell in love with the unique art style. It turned out that not everybody shares this love for that art style, unfortunately. No. And it's okay. It's okay. There's fans out there, and it's either they are like super excited about it, or they go like meh. Yeah.
Right.
And we can't help it. So it is what it is.
Yeah. And I guess Thilo kind of just touched on this, you know, but yes, like the reasons why is yeah, the asset creation was simpler and it was definitely faster for us. You know, and we'd already decided on dots for our automation game, and so like actually pursuing kind of a high performance voxel engine also made sense. It kind of fit neatly into that box of high performance. So so it's just like the stars kind of aligned here. It also unifies everything in the world. So it's like everything is a voxel, even the dirt, it might be like a copper resource or, whatever, but it is just a voxel with some material. And if something like shoots it, for example, it's the same as if, it was a piece of metal on a door or, whatever. And it gives a lot of, feedback to the player.
Actually, like just sorry, the point before asset creation. Are you doing asset creation? Where are you assembling those voxels?
Yeah. So we use Magic Voxel, and so it's super simple. It's just like a 3D editor.
Having a stream about Magic of Voxel next week, maybe even 1 week from right now.
Yeah, it's incredibly powerful. Yeah, it's really nice, and I think Thilo's now like very well versed in it. And our artist certainly is as well. And really like just for us, we have some kind of like unique specifications. Like over here on the left, there's some material data, which I'll touch on a little bit later. So the asset creation is like very specific for us, but it's also like, really quick. Like if I want this to be a different color, I can just, paint over it as something and then save it and then load it. And suddenly it's different.
So if I understand well, you have kind of two classes of voxel in your game, like the ones that are just the art style of assets and then the actual voxels of the terrain.
No. So we use, like voxels just in general, like I think a lot of people when they think of voxels, it's like Minecraft or something, and so we're like visually using voxels or voxels, but then we're also using them as like a data structure for like a lot of certain things, and like other games like Astroneer or No Man's Sky, they might use voxels and then use like marching cubes on them to make them, like a normal looking mesh. Whereas we just stuck with voxels, but it really is just like some data, some volumetric data that we're using. Yeah.
Beauty.
Yeah. And then really like a lot of it's just limited by the imagination, and then also obviously implementation cost of like doing some of these things. What I was just saying is yes, we use Magic Voxel, and basically, we load these at runtime and just grab all the models, all the voxel data, the physical type, which would be like the stuff on the left, which has to do with the palette row that it's in, and then the material data, which if I swap back real quick, that would be over here, and basically you can see the material data, and you can just change it, and then as soon as it's loaded the next time, this also would come right in. So if I want this to be concrete and emissive, this would come in like that basically. So it's really quick, really powerful. Oops. And then basically, this is what our Voxel material data looks like. It's more or less like a one-to-one mapping from what comes in from Magic Voxel, and we just store that in a native list with, and we try and kind of keep them together. And then the voxel data is just stored in a native array.
Maybe you can show this in game for a second by using the debug physics thing on a pawn. Just dig down to his bone.
Sure.
The first like aha moment when I started playing the game is like, oh my god, the mine is actually mining the ground. What's going on here?
Right,
And then it just ended with a big hole, and I'm like, oh my god, okay, that's a new dimension now.
Yeah.
Right.
Also, while we're looking into this art style, when we decided to go with voxels, we had like problem finding voxel artists who were free, because everybody was like working on these crypto things, and nobody had time to work on our game or help us in working our game. And then we had also the issue that it was super hard to find somebody who could make characters which do not look cute. Because if you Google voxel model, and the first thing is kind of just little guys, and little cute, etc. But make them looking serious, it was so hard. But now we have them with everything. I mean, we talked about this material, so they have like bones, they have flesh, they have the uniform, and Tony's going to show you. So if you're going to dig into the head of somebody, I don't know if there's like any rating on the stream.
Yeah,
but you can also see and hear it.
Here, let me hide this. Turn off.
You have like your gizmos on,
yeah. So let me kill this guy because it actually doesn't do anything, but eventually he'll break into pieces. Yeah.
Oh
yeah.
Wow.
That guy does, but like over here you'll actually see destruction and
well, so you can, so let's say like you put a little factory or something. Can you actually during the game break apart that object?
It can break apart if it gets hit by something, like really whatever it is, whatever.
That's really cool.
Whatever you have, so like if I just have this guy start shooting this thing, but so pretty much like if they are hitting stuff, these things will break apart and fall basically.
Oh, that's pretty cool. Yeah, that's the usual like shortcoming with voxels is that like you don't have the physical parts. Do you have that like physical simulation of the parts that are separated from the ground, just for assets or for the entire world?
Yeah, it's mostly for the entire world. I mean, so like if we were to look at something like, I guess like this machine, which actually moves, these are just being animated, but like they can still be destroyed. Okay, so I guess that's like metal or something, but
they're metal.
Yeah. Okay, then I'll try and find something that actually can be.
When you alter, I'm really confused. Wow, like that dimension is absolutely incredible. So when you alter that object, does it still produce what it's supposed to produce, or does that like influence the simulation?
At this moment it doesn't, but we have plans that it breaks down as soon as it is like at 50 HPA or something.
Oh, that's really cool.
Yeah, I'm trying to find something that's not metal. Yeah, because I'll touch on it more, but like we have a kind of material thing. You can see all these materials here, and they mean different things, but it's like these blue are metal, and so they won't break with. Yes, this is light metal, and this is like heavy metal down here, and so these won't break with like normal just destruction. Whereas something that's like yellow.
You're dealing 15. Damage, which is not enough for light metal.
Right. Okay.
Which is enough for flesh. So.
Yeah. We actually had to. The reason the agents don't really break down is because we had to disable it, because like they ended up walking around, they like didn't have a head or they didn't have arms, just because they got hit by like a couple of things, and because they're just like a couple of voxels, like their just arm would like just be gone. And it ended up looking kind of strange.
And the 3 animation, so like this is really fantastic. It would be very difficult to do like with something else than ECS. Well, it feels like I'm selling my stuff, but it's actually true. Like that would be very, very difficult to do if you didn't have like a very scalable system like ECS.
Yeah, I completely agree. Yeah, don't do that. Yeah, I completely agree. Like it's very much like very performant. Everything lives in components. On the very next slide I have something about this.
Also, while you're talking about the materials, maybe you can set that swarm on fire just to show this. So everything can also burn, explode, etc.
I've got it coming.
You got it coming.
Good.
You're spoiling it.
Yeah, I do want to make sure that we're being cautious of time. We have about 30 minutes, and I know we have a lot more to get done. We might have to make some choices. I know we've talked ahead of time about things that we might skip through just in the sake of time. So just as we're aware, I'll kind of let you get back into things here, just as long as we're being cautious.
I'll blow through this. Don't worry. Okay. yeah, so basically the way it works is we have one entity per voxel object model. So things that are like the wall that doesn't have multiple models, that is just one single entity. And then things like, like the mining drill that has like something that spins. A lot of times it's something that's animated, and that will require a multiple model kind of setup. And basically, yeah, every single entity has a brick map, which is just like the voxel data, and then some attributes. And really the important thing here is like to try and get the amount of memory per voxel like down as much as possible. And it's like in this case, we have this voxel object palette pointer, which is also material property because we use it in our shaders. And this points to a start index. So like if we were to look at this, there are 255 palette indices here, and we kind of just make these local so that this wood wall, it will have a palette pointer that points right towards its 255, up to 255 run of materials. And with that, we don't have to keep an int, so we save 3 bytes, which is great. So really for anyone like getting into voxels, you're going to have to do some bit packing. You're going to have to learn about bitwise operators. There is no getting around it. The caveat here is if you're not doing high res voxels, just forget what I said because you don't need it. Okay. you won't run into those limitations that fast really. This is really like I said, when we do our optimization passes, this is like very important when we're dealing with millions of voxels, like millions and millions of voxels. And also we have this brick grid cell to brick map thing, which here I can show this again here, where basically like a brick grid cell would keep track of an 8x8x8 set of voxels. So like if, for example, this piece of them, is destroyed, we don't have to upload the rest of the model. We just have to say like, okay, this brick grid cell is dirty, so upload those changes to the GPU and then run some logic like specifically there. And that's kind of the way it works.
What's the rendering pipeline?
Yeah, so we're using HDRP. We had a custom like fully path traced engine with compute shaders, but what ended up happening is I was working like so much on like all these different things that were not the game, that at some point we ended up swapping and just saying like, okay, like Unity has a team working on this. It is, they can do more than I can. So I had to take the hit, and I'd still like to come back around and try and do like some ray traced shadows, things like that. But for now, we basically have ray marched objects. So like if I show this, everything here is in a box basically. So this is kind of like a peek behind the curtain. Yeah, everything is just a cube that we ray march into, and so it's all like custom shaders, and there's some more slides a little later on this. But it's HDRP. No, I'm going fast. Okay. So I'd already said this. Yeah. So we skipped ahead. Changes are directly made to the brick map, which just holds, again, a material ID. And if that material ID is 0, it means it's empty. And then when that updates, we basically mark the brick grid cell and just say, yeah, this thing's dirty. We have some change. Add an action component, and then it goes and does all the updating it needs to. Okay. And then this is just real quick about our rendering. So all the voxel data is ray marched. We pack it into 16 ints per brick grid cell, which ends up being the 512 because 32 bits times 16. And we use Morton order or Z curve ordering. And basically, this one mess of colors here is like not a great example, but over here you can see kind of how these are packed into bits. and kind of how you can do some space skipping with these. And basically the way it works is when we're uploading it, we take all the voxels and we just pack them. So if the voxel is solid, it gets a 1 in that bit. If it's not, it gets a 0. And then we only upload materials for solid voxels. And so this helps get like our memory cost down, and brings like the bits per voxel down on the GPU. And we basically just use get count bits intrinsic to figure out the correct material index.
Somebody could maybe argue that keeping like your memory, maybe fixed would be probably simpler, like for cache management and so on. But like you basically like very dynamically go up and down in memory usage.
Yeah. We definitely do have like some stuff like that. Yeah. We do end up like growing fairly rapidly, but then also like clear stuff out. And so we reuse these structured buffers. Or are you talking about like CPU side?
I guess a little bit of both, I guess. But in general, like what's the global like memory budget you need for a reasonable level?
Yeah, I think it's, yeah. Do you remember, Thilo, what we ended up sitting on?
Yeah, so only for the world tasks, we had 4 gigabytes, and everything else is 2 gigabytes of VRAM. So
That's not bad.
Yeah.
That would be worse with just regular textures and meshes, wouldn't it?
Yeah. And one idea I had is like to fully instance the voxel data, because like right now we do add the voxel data into buffers, even if there's no changes, and really, we don't need that. We could use instanced colliders. We could use instanced, voxel data. We don't even need it, and just point to like the instance data on the GPU until there's a change, and then actually do all the things that we need. So that is like a potential optimization that we've also thought about. And then about the rendering, yes, we use this multi-level DDA, which is this discontinuous deformation analysis, and basically it just is like a way to go from cell to cell and make sure you're not missing any cells while we're going through. So this is like a 2D view of this brick map. What I was talking about with this Morton order, this kind of shows how we end up doing the space skipping, and why the brick grid cells and brick maps are actually like really helpful. So basically, like in the top here, you see, actually here, let me swap over. I have this open here. Yeah. So this would be a brick cell that is empty. So it has no voxels. And this whole thing can be skipped. So this ray goes straight from here to here. And then basically, this brick cell has some voxel data. So we have to step into it. And because we're in Morton order, we can just check this 64-bit mask here. It's a 0. So we don't have to go any deeper. And then we go over, do the same thing. This one has voxel data over here. And so we can go 1 lower, but then we do more skipping, which is great. And then, this we have to check like the lower level voxels, skip, large skip. And then finally over here, we have a hit, but just looking at it, like it is much more performant than just like a naive, let's step through every single thing here. Yeah, so what I was saying, or what I have here is just like implementation tips is, pre-compute all the Morton ordering data ahead of time. That'll be really helpful. We just have it sitting in this big array. And then also, like I said, you're gonna have to learn how to work with bit operations. We do a lot of like bit shifting to go between levels. Because it's just like a multiple of 2, you can just bit shift it, and then you're in the upper level of your cell. And that's kind of the way it works. This is how like all of our data is structured on the GPU there. What's nice is that because we have it structured this way, we also get these free LODs, where basically if the distance from the camera to wherever you are in your voxel object is greater than this LOD max, you just early out at this level. So like, for example, you might early out right here and end up with like a 2x3 if you're at that distance. And yeah, these are kind of fudged just so I can get better pictures, but it actually is like, yeah, fairly unnoticeable. Yeah, the only thing is that for our game, we're top down, so you don't actually really see this, but we do aggressively do it for shadows. So like if I were to go over here, oh, actually, let me turn on shadows. Yeah, like as you zoom out, they change LODs, and it ends up just saving a lot on rendering, and like stuff that's like out in the distance. If you have like a, like are coming to like a dawn or dusk or something, or tracing these higher levels is way more performant than the alternative. Yeah. Okay, and then
it's since you have like all of this voxel hierarchical structure, that's you're even saving steps, because that's pretty much what you need to do with like large meshes of environment, like break it down in hierarchical,
right,
KD trees or something. And
yeah,
you're like, you have all of that for free.
Yeah. It's really, really interesting. Yeah, and yeah, like it definitely is more expensive, and since we're using shadow maps, this is like the worst case. Is having to redo the tracing with shadow maps, and that's kind of why we're so aggressive with the shadow rendering. But yeah, it is like very much just a big optimization, basically. Yeah, and I guess this is what Thilo was kind of talking about earlier. So we have various materials. I said they come from the Vox files, and they might be things like wood, dirt, metal, flesh. We have like a big list, and with these we can control, like interactions and behavior. And this is really where it gets interesting. It starts getting really cool, like some of the stuff you can do. And here's just some pictures of like, well, yeah, I can also show this in the editor, but
it was better in the editor.
Right. Yeah. So you can kind of jump between them, and it's also a good like test every once in a while to check and see like, okay, does everything have the proper materials? Does it make sense? Because it's very easy to like not set it up properly. Like I just saw, for example, like this carpenter's bench, which I think is wood, is made out of dirt, I think. So this will actually like have different interactions. Like if I try and set it on fire, it doesn't set on fire, basically. But
okay, that's my bad. I'm sorry. I'm fixing
no. Yeah. Yeah. So let me head to the next one. Yeah. So also with this, we can basically assign a density to every voxel physical type. And then with this, we can calculate the mass of really any voxel size. So we actually have like 3 different voxel sizes. We have like the normal one, which is 20 centimeters cubed, and then we have some smaller ones for agents, and they can all just use this density, and we just grab out the mass. Yeah, and I put a note here to double check the units if you're doing this, because if it's like too much or too little, it's completely wacky. But what's great is that with this, you can, calculate a physically accurate center of mass. You can calculate an inertia tensor, and then basically you just pass these into the physics mass. There's a create dynamic physics mass, and then your debris or anything that is like a dynamic physics object will automatically kind of have these properties.
What it's again? So are you telling that every single voxel is physically simulated every frame?
No. Only ones that get like broken out. So we have debris, and then actually the debris will also like come to a rest on the ground, and then like more or less go to sleep. Yeah. So it is not like we're simulating everything, but once they break, we assign.
Well, I mean, you kind of simulate everything, but you're just smart in not like overdoing it.
Yeah. So basically, like we just assign the mass properties. Whenever there's a change, we just go through, recalculate them. Yeah,
it's pretty cool. Everybody's always been trying to do this. Like, it's probably one of the game that is getting the closest to that, like, amazing idea of everything is having its own like simulation, and it's cool.
Yeah, and it really comes from like I said, Teardown was like coming out around the time that we'd started, and the guy who made that, Dennis Gustafson's just like, he's a genius. He's like this incredibly talented physics programmer. A huge inspiration for sure.
This is cool to see. Very, very cool.
Yeah. So then, outside of this, let me check the time. Okay, I'll speed through this real quick. Okay, so buoyancy. Let me just show it instead. We can forget what I wrote. Okay, so, oops. Yeah, so pretty much, with that, since we have all this physical, data, we can also, figure out certain things by it. We have physically accurate, buoyancy. So things that are heavier will float, and things that are, or things that are lighter will float. Same with like these wood walls. Yeah, so these will all kind of just float in the water. It's really cool.
Something getting into the water, does that affect like the density of the water? Does that push that water out? Or
no, it doesn't. No, it's super basic. And actually has like really no.
Yeah.
Really,
I'm not joining your design team, or I'm going to be like, oh, we can do so many
right. Yeah. So what I mentioned here is the start is like a weekend project. Is just like, would be cool, and like it's really hard to resist like the allure of like a sexy new feature. Once you have like all these possibilities, it's very, very hard to not just go for it. Again, the note here is it'll be much faster if like, you take something like wood, which I knew would float, like these bundle or the logs, and basically use that as like the tester to make sure everything's right, because like the numbers are a little fudged, but it looks fine, so it's all good. And then there is destruction. So we kind of touched on destruction, but I'll head back over here. Actually, let me load up this. I'll just build a new house. So everything is destructible, which is really cool. Oh man. It gives a lot of like interactivity. So whatever kind of damage, a lot of times I'm just using like our debug damage, just to kind of see it. And so we also have like a floating voxels system. These are all systems that will run. And then we have fire, and this will actually spread. This is another system that's like a burning voxel system, and it just takes our buffer of burning voxels essentially. Oh shoot, these guys are
really good at
they're good at their job.
They're very good at it. Yeah.
No, we had them like really bad at firefighting, and it got out of hand suddenly.
Yeah.
So we balanced this like 10 times by now.
Mm-hmm. Yeah. And also what's cool is like is this is like one time where we dynamically change the voxel material. So when something burns, it becomes charcoal, and then it has like a different density. It has different behavior. Like if it's damaged, it'll kind of dampen the force less.
What about the smoke?
The damage? The smoke is just
particles. That's just particles.
Yeah. Mm-hmm. Yeah.
It's very disappointing.
I know. Yeah. We do have like a very light wind sim that we run. Right now it's just like a super basic compute shader. It's super basic wind, but that's something that we want to look at.
That's very cool.
Yeah, thanks. Okay, well, I'll leave this running for now. Okay, so that was destruction and fire. Okay, yeah, just real quick. Yeah, so some downsides is we obviously took this huge detour actually working on this. So there's like a big upfront cost, and because it's like so dynamic, it means that like every system or feature you have to like think about. Like in the bottom right, we were talking about structural integrity, and kind of the question became like, well, like what happens if a voxel is not connected to another voxel? Like, do we want to even take this into account? You know, it's like a huge rabbit hole to accidentally go down. You know, it's like really easy to just start over engineering things. You know, because when you're a voxel engine developer, everything's a voxel basically.
Yeah, you're on a molecular level somehow.
Right. So yeah. Yeah. I become voxels. Yeah. Exactly. Yeah, it's just like more complex to work with in general. Yeah, and that was that segment on voxels. Yeah.
Woo! Well, thank you very much. Very thorough. And we can go a little bit over time. We do have to be cautious that we're not going too far over time. I know that we have a couple of dedicated segments that we wanted to talk about. The serialization and deserialization of large worlds perfectly with dots. But then also we kind of wanted to discuss the mod scene, and I want to make sure that we have time for both of those. So are we okay with that plan moving forward, that those are the two topics that we touch on and make sure that we get all the information out that we wanted to?
Fine.
Yeah. Sorry, I missed. What was the first one?
The serialization and deserialization of large worlds perfectly with dots.
Yeah.
So without covering the topic, I think it takes one sentence to talk about pathfinding, though. Just give us like one hint of how you, because this one is interesting in a voxel world. So
yes. Yeah. So we use HPA, which is hierarchical pathfinding, and yeah. So we do use the voxel data for pathfinding, and it's like as you terraform stuff, we will add new nodes to this, and so people can actually just walk right onto these things. Yeah, it's very, very cool. There's a great talk. There's a great GDC talk about hierarchical pathfinding that I have in my resources part, and yeah, I have like some.
And how stable is it like right now? Like, are you having like a very good solution that is stable, or are you still iterating on that?
Still iterating on it.
Yeah.
Hard.
Yeah, but it mostly works. We have some agents getting stuck. That is what we have.
Well, I guess when you got a mine factory, it's just creating a big hole, and like it's pretty difficult to get a sense of if I'm jumping in there, am I going to be able to get back?
Right. Yeah. So here's just like an idea of kind of what these look like. So basically, we're doing pathfinding. We hit, we try and use the like highest level that we can, the highest level nodes, and when we need to, we go down and down, and so these are like the lowest level nodes that are walkable, and basically what we do is we just try and hit the top level, and then do our pathfinding there. This is like the cheapest thing that we can do, and whenever there's updates, we will generate new nodes and delete old nodes. Yeah, it's very much based on that talk. So the
intersection of pathfinding and destruction is like always a kind of forum, and it feels like, at least when I tried the game, it was actually pretty good. Like I was pretty impressed that it wasn't getting crazy fast.
Right. Yeah. There's definitely like edge cases, where people get stuck in things, and it's like something that we're actively working on.
Yeah, I mean, of course, there's also like some UX problems. So people getting stuck by digging a hole, and then like, okay, how do they come out now? And you have to make a ladder or something, or a staircase. Yeah. So.
All right. Yeah. So I don't want to take too much time on that topic, but I felt like this one was like, it's very, very fun. But if you want to go to serialization, let's go.
Yeah.
Mm-hmm.
You can make some Azure like staircases in this game. That's possible.
I could nerd out about those things like for days. So
yeah. This guy's stuck now.
Yeah. I was just trying to say that because we use voxel data, like I can split these. Oh, whoops. Yeah. Well, anyways, well, so just imagine there was damage that would split it, then basically it becomes unwalkable, even if there is like things. So like it's like wherever there's a hole, it just like dynamically updates the like the node graph. And
yeah, that's probably something you need to resolve at the gameplay level. Like, when an agent's being like
exactly
not able to do anything for a little while, then maybe a drone gets there and take them back or something.
Well, in The Sims, they were like looking at the camera and waving their hand.
Good idea. Yeah. Oh, can you actually grab people and move them over?
No,
like in
no.
The Sims, no. That's for other game developers to make.
Yeah, everywhere against the fence or something.
Yeah.
On fire.
yeah. If they're dead, you can. Yeah. Otherwise, I just always just move them and move them like this in the editor. Yeah. Okay, let me go back. Okay, yeah. So then the next thing is serialization deserialization. Yeah. So it is very important, right? We have like a very complex game, lots of items. It's really important that it loads back properly, and they should really be in the same state when you load it. And this turned out to be like pretty simple, honestly, with ECS, and it actually just ended up becoming like one of the strongest debugging tools that we have. And this is kind of like what we do. We have a in-game bug report tool, and basically you can open it and submit a bug report, and it goes to our Discord and it attaches a save. And so basically, like if somebody's having some problem, they say like, yeah, our agent's stuck, or like this conveyor belt's not working, whatever it might be, they submit this, and then we get a save and we can load that. And then, we load the same exact component data into the entities, and like because of that, and like all the same systems are running, we should ideally be able to reproduce this. And in like 95% of the cases, this is true. Some things which are built like dynamically, might kind of solve themselves, like pathing, for example. We were just talking about that because we'd rebuild the graph. So basically just looking at it, like looking at an archetype, we have just chunks with some data in them. And if we really just take all these, for example, like translation bytes, gather them all and stick them in a file, we can load them back out. And so from a chunk, we can get a native array of bytes, and that is all the component data. And serializing this is like a trivial thing. So here's like some steps. So pretty much what we do is like we create a new world, we move all the entities over, and then also we update the parent system because they won't have children if you move them. And then we remove any unneeded components. We basically just have some queries and like a component array that are things that we don't need. And then we also have like some very specific things for like changing things to serialized versions. So like damaged voxels, for example, we don't need to store the whole brick map. We just store, like a serialized brick map component, which is new. So basically when we serialize, we run a new job that takes the brick map data and then adds this component, removes the other one. And then we actually do a remapping, which is just updating the version number. Next we gather all the serializable type manager and type info component and buffer types. And so this is either something that has the serializable tag on it, or we added a new attribute, which is save component. And with this, we can either say like, yeah, we want to keep the data or not. An example would be like a entity that has a link to like lights that it spawned or something. We might want to keep this, but the lights aren't going to be there when we regenerate it. They'll come back in later, but we still need the component, but we don't have to save the data essentially. And then anything that doesn't have components or buffers, we don't need those. And then all we have to do is loop through the savable chunks. So you have a query and you get all the chunks out of that. And there's just a function. It's get dynamic component data array, reinterpret, and you'll just get your native array of bytes. And you can add that to a component bytes list, and that will end up being your component bytes list. And then you just save that. So
and then it's stateful version of the level, right? It's the entirety of the data, that level.
Yeah, exactly. Mm-hmm.
Is your, I guess, like, since 80% of the code is based on ECS, I guess the word evolution is deterministic. Like, have you thought about maybe some ways to keep track of changes instead, like at the delta basically of what happened in the world, as opposed to take a snapshot? But maybe a snapshot like brute force is better.
Yeah. So like I was saying, there are certain things that are like that, like where it's needed, we'll keep track of stuff, but like the big things would be, like if we have to keep track of like all the terrain changes, for example, or things like that, and in these cases we do just save out the dirty stuff, and then when we regenerate, we then apply the changes after. But for a lot of things, like we do end up needing like all of it essentially. And
have you thought about multiplayer in the future?
We've talked about it.
Maybe then that's going to become a consideration. Like if you want to, keep very like precisely have just the data you need to transfer from one player to the other, then maybe kind of data strategies about the world will be important then.
Right. Yeah. I think there's a note in here somewhere about that. Maybe on the next slide. Because like the problem is that let's say you don't serialize something, and then you end up needing it, like this data is just gone. It's been wiped. So a lot of times we kind of end up just doing more than not. And actually sometimes these things are also hard to track down. Like if something isn't serialized, it's like I'm trying to think of like one that we just had. But basically on load, we were having an issue that you basically only see when you load the game, and you could never reproduce it without saving and loading, essentially. And so these are like some of the potential problems, if you don't end up saving the right stuff.
Yeah, no, it's definitely difficult, especially like in multiplayer. That's I hope I'm not rabbit holing too much here. But
no.
if you were to, for example, just recording the entirety of the gameplay inputs, technically you should be able to exactly resimulate the world in the state it is. Or it probably depends on the length of the session, but
right. Yeah, and this is basically like our first crack at it, I would say. And once we had it implemented, like it basically fit our needs perfectly. And gave us like the functionality that we were looking for. So
I'm not criticizing, like
no, right.
We're designing a new game like right now.
Right. Right. No. So this is our format. Yeah, we basically just gather all the component information. So that's like the staple type hash, the element size. We also serialize the name, just because it's easier for debugging if there's problems later. You need the entity count, and then the indices that actually have this component, and then just the array of bytes. And yeah, that's really about it. So actually I say right here, it's important to think ahead, like what you might need, and just include it. We didn't have this element size, and it was like a super headache. We had to brick like every save just to kind of move forward. And also just a note that relying on the type hash is like a brittle thing, because if you change the component, you need to make a migration. And then the buffers are just slightly different because they have a dynamic number of indices, but it's very similar. Anyways. And then deserializing is basically just the same thing in reverse. We read out the component bytes, we take that type hash, we look for the type, and then set the bytes. There's the same kind of function. So we just grab the byte array, the native array of bytes from the chunk, and then we just mem copy the loaded stuff right into it. And the only caveat here is that if the stable type hash is changed and you have a migration, then you'll need to run a migration, to kind of update those.
Maybe can you for the part of the audience that might be not super knowledgeable about ECS, like can you uh, uh, say a word a little bit about like why is that like efficient in that context? You know, like the kind of in memory, just move that whole set of component data from disk to memory and things compared to like doing it with game objects, say.
Yeah. I mean, it's super fast. Like because the way the data is set up, you know, like that is like the strength is that you have like everything in these contiguous, you know, memory chunks, and it's just really fast to, you know, go through them, you know, because like you basically load everything into your cache, and then you just have the data. You don't have like a lot of misses, and you know, it's just fast. Yeah, that's really what it comes down to. Yeah. Yeah, I think I've kind of got to speed through this. Yeah, so this is just more like implementation details. So we use the entity remap utility to do remapping. And then we also run some specific migration some migration logic, but then we also have like some systems for things that need to happen at the end. You know, so like taking those deserialized or the serialized brick maps and then changing them into brick maps and applying that data. So that also has to happen. And with that, once you copy the entities back over, you have the world in the same exact state as you did when you saved it, and it works really, really well. Yeah, this isn't super important. Yeah, probably the most important thing here is that like this is a general solution. You know, it's not something unique to us, so it would actually work with any project using dots. And again, like anything that's not component data, you have to make sure it's watertight, because this will also affect your simulation. You know, like for us, if like our quests or trades aren't set up properly, then it doesn't matter if you brought in every entity and like all of its data correctly if like they're pointing to invalid data. Yeah, and
Awesome.
that's about it.
I can take all of these links and make sure that they're in the description of the video. So thank you so much for providing like follow-up resources for people. I did take the GDC talk and put that into the chat when you mentioned it. So we'll make sure that all of these resources are available for people as they follow up with it. As we are running very short on time, I want to make sure that you guys have the opportunity to talk about modding. But I know we are doing a giveaway here as well. So what we're going to do is both. The giveaway is open. If you would like to enter, go to twitch.tv/unity. Make sure that you have an account there. Use !giveaway in that chat. I will pull 5 winners and send them codes after the stream. So everyone gets one entry. Head on over there. And then Tony, Thilo, I know we wanted to encourage people to join the mod scene for Dawn Apart. What's that been like for you guys so far?
Yeah, we were blown away by people starting modding the game, and just right out of the early access, we saw mods popping up left and right. So I think the first mod was a Japanese translation of the game. Somebody did. Then first-person camera, free camera, all that stuff came out of the woodwork. Basically, in the first week when we started the game, we made the game so that it is really easy to mod it. I mean, you saw that the voxel files Tony just edited. You can basically change every voxel mod in voxel model in the game by yourself with Magic of Voxel. You just load up the folder and you can start adding new ones, changing them. The XML files, which get read when you start the game. So basically, Tony and I, we were joking about wondering what the first game somebody is making out of Dawn Apart. Because basically you can do that. You can say, well, I don't want to have a factory automation game. I want to have a medieval city builder or something. You can do that actually with the game we have now, and we want to see that, and can encourage people joining our Discord server, start modding the game. And if you're a game developer and the stuff you just saw and maybe you want to build your own game based on Dawn Apart, you can do that. Reach out to us. We're on Gamescom. We're on our Discord server every day. Yeah. But if you're at Gamescom, find us in the indie area and have a talk with us.
That'd be really cool. And if you do, post a picture to either the Unity Discord or discussions page to let us know that the Unity community connected with the team behind Dawn Apart, which is really, really cool. Okay. We are going to keep this giveaway open for a couple of more moments here. Again, if you want a Steam key for Dawn Apart, we're giving away 5 of them, ! Giveaway at twitch.tv/Unity. And I have been putting the Discord link for the Dawn Apart Discord. Do you think that is the best place for people to get started if they were looking to mod?
Absolutely, yeah. Or in Steam and discussion board,
yeah. We're very active on our Discord, so it's a perfect place to get a hold of us about anything really.
That's awesome. We basically stream we do everything. We stream our dev meetings, everything. Wow. At the beginning, we were like, okay, what kind of content do we fill the Discord server with? We're like, well, maybe the stuff which we're working on. And so basically now people can look at our desk while we're working.
That's awesome. That transparency is probably unrivaled. Like there's a lot about kind of transparent game dev and going through and uploading devlogs and updating every week, but you guys are doing it live, and that's really, really impressive, honestly. Is there anything else that we wanted to talk about with the modding? Any other tips or starting points for people?
No. I think the only thing that I have to say that Thilo didn't really touch on is yeah, basically like the whole game, we've built it kind of with that in mind. So like once we implement something, like basically Thilo's been making all this content and this is like completely separate. This is no code changes. It's all just like player facing data. Like if you want to add new items, you want to add new buildings, new recipes, whatever it is, if you want to change the, like the cost of something or whatever, it's just completely out there for anybody to do whatever with. The only thing we don't have right now is like some like higher level scripting or something, but that's definitely on the back burner.
I love that. I'm going to pull the 5 winners here. I'm going to rattle off your names. If you won, keep an eye on your Twitch DMs. I will be sending you a message with your code either later today or early next week. So those winners are DT Twitch L. We've got Scallywag Me, Altultor. Got that one right, 100%. Random Gaming 2099 and OG Mr. Awesome. Keep an eye on those Twitch DMs, and we'll be sending you over those codes. Laurent, thank you so very much for returning to the streams, for sharing your deep well of knowledge with the group here as well. And Tony and Thilo, thank you guys so much. This was probably one of the most in-depth, informative technical streams that we've had. So I really appreciate you guys. Again, not just putting in the time to be here today, but all of the prep work that you guys did ahead of time to make sure that we were ready. You guys were incredible partners to work with, and I'm so grateful. Anyone in the Unity... Of course, anyone in the Unity community not yet convinced, please go and check out Dawn Apart on Steam. It's absolutely incredible. So please go and show some love for the team. And with that, gang, one final thank you, and then we'll send you into the recesses of the backstage space here on the stream. So thank you again, Laurent, Thilo, and Tony. See you guys soon. And with that, Unity community, just you and I, of course, we have another stream next Tuesday. I know that today's stream ran a little bit long and we did not, unfortunately, have time for Q&A, but keep an eye on the discussions and Discord pages as we will always have opportunities for you to ask questions and find answers. Our next stream is next Tuesday, and oh boy, is it a doozy. Oh boy, is it a doozy. We've got what's new in Unity 6.2. Of course, 6.2 releases into the wild, I believe today. I think it's already free. It's out there for you. Go and find it and chase it. But we will be going step by step through all of the new features that will be added. That's on Tuesday, August the 19th at 12 p.m. Eastern, 9 a.m. Pacific. That's 5 p.m. GMT. And we'll be sitting down with the people that are working on these features to tell you exactly what to expect from them. So go and get 6.2. Check out the discussions, post about all that information, and come back and see us on Tuesday. Ask your questions. They are so often so excellent. And with that, Unity community, we are going to wrap up today's show. A big thank you to everybody who helped put this episode together, and an extra shout out to Jack, working behind the scenes to make everything run smoothly here. Unity community, until I see you all again, my name is Jackson. Have a great rest of your day.